Okay, so last class, this didn't work. So if it doesn't work today, I'll also re-record it again after class and post it, but hoping this one will be captured. All right, so there are two parts to this. The first part to the topic will be correlation, and then the second part will be linear regression itself. I'm going to be dealing with simple linear regression, like the very, very basic one. And so we're saying here that correlation is defined or talked about in three ways. You can talk about the direction or the strength and the shape. And it is something like this. It's normally a bivariate relationship, right? So your goal is to capture, how two variables are related. And usually these are continuous variable, right? I hope this doesn't slow me down today. These are continuous variable, right? Continuous variable means that they are measured data, right? So it's not going to be anything counted. Okay, but it's not working out very well. Let me see if this will go. Okay. As good as the ones in the class. Okay, we'll try to manage. All right. So they are normally continuous variables. So you have two items. Maybe this is height, for example, and this is weight. And what correlation is trying to do is to, let's say you have a sample of 50 individuals, and you measure their height and weight, and you're going to plot them here. So you pick each person to match wherever the height is and wherever the weight is. So at the end of the day, you have these dots all over the place, and this is called a scatter plot, right? So this will be for a relationship where they are going in the positive direction. So this is, in terms of direction, this will be positive, right? You could have a different relationship where it is negative. So again, I don't know what to use here. That would be a good illustration. Will work. I didn't think about this ahead of time. Okay, so let's say you have a variable here, y, and a variable here, x. And relationship is such that as one is increasing, the other one is decreasing, right? So if you plot them, you have something of this nature, okay? And I think I should use a different color to kind of capture this so that it will be color-coded. So let's use green here. Let me first of all erase here. That is not working. Okay, so I'm going to use green on top of that. So let's say we have this. Yeah, so you plotted the data and it shows this way, right? So this will be a negative relationship. Okay. So in the positive one, you see that, let's start with the negative one. In the negative one, you see that as x increases, right, y will be decreasing and vice versa. So let's say, for example, you have a value of x here. If you plot that to the graph, you see where it meets the line. Don't mind that it's not very straight. If you take it to the y-axis, this is the point you have. So you have a value here. Remember, this is 0, right? If I pick a value bigger than this one, maybe somewhere here, and I plot it to the graph, and you take it to the y-axis, okay? So you see that if this is value number 1, this is value number 1 here for y. And if this is value number 2 for x, this is value number 2 for y, corresponding to those x values. So you see that as x becomes bigger, y actually becomes smaller, right? Okay, so maybe we should call this, okay, not to confuse it. Let's keep it that way. So if this is 0, right, the value here is bigger than the value here, isn't it? So, and the value here, the bigger value is associated with smaller value in the x-axis. And the smaller value in the y-axis is associated with the bigger value in the x-axis. So this is a negative relationship, okay? Here, they are positive because they increase in the same direction. So if I pick a value here and trace it to the axis, trace it to the y-axis, I have it here, right? So let's call this value number 1, and this will be number 1. If I pick a bigger value here and trace it to the axis, let's call this value number 2. Come over here to the y-axis is value number 2. So again, you see that the bigger value of x, right, give you a corresponding bigger value for y, and that is why it's a positive relationship. So that is one way we can define correlation, okay? A second way is to talk about the strength. The strength will be dealing with how tightly together are these lines, these dots. How tight are they? So the one I drew now is pretty tight, but let us take another one illustration. So if I use blue, I'm going to just use only the positive to illustrate that, right? But it could also be on the negative, right? So if I use blue, and I have this line, this way. So this is a bunch of items and people were measured, and this is the relationship. Okay, so if you look at this, you can still see a positive trend, right? But it's not as tight as the one we have here, right? So we use that to define strength. So this will be weaker than the one in red, right? The one in red will be stronger. So when you define both of them, you see that these two, let's label them, let me use black to label them A, B, C. Say A, B, and C. If you look at A and C, you see they are both positive. They are trending positive, right? But A is definitely stronger, more tightly, the points are more tightly placed together than C. So C is weaker than A, okay? So, excuse me, writing here, so in strength, we talk about weak. We talk about strong, but some people also bring in something in the middle, say moderate. And then you talk about strong. Okay, so, and then finally shape. Shape will be like, let's use purple. Shape will be something like this. Everything I've drawn here on the board are linear in shape, right? They are straight lines. You can put a straight line on A, straight line on B, and straight line on C. But imagine it's possible that you have a relationship, let me say, age and performance in a sports game, in a sports event, right? So it will go something like this. The younger the person is, the chances that the performance is higher. And at a certain age, it kind of plateaus. And people normally retire at this point, right? People monitor that and say, okay, this is my peak, the peak of my time in this thing. Let me get out of the stage when the ovation was highest. But if the person continued, then you're going to see performance start coming down, right? So this happened in many situations in life. So the situation you have here, let's call this D. Let me use black. The situation you have in D is not a linear relationship. It's a curvilinear relationship, right? So you also talk about shape when you're describing correlation. So we will say linear here. So in this class, we are focusing on the linear relationship. So you don't have any reason to use a curvilinear relationship because we're just trying to touch the surface of everything. So what happens here is that when you have a chart this way describing a bivariate relationship, then you can describe them based on these three attributes. So if I take A, for example, I will say the correlation or the relationship between height and weight is linear, is positive, and strong, right? I could pick up these three words to describe it, those three adjectives, right? I'll say it is linear, 1, it is positive, 2, it is strong, right? But if I want to describe like a C, for example, I would say it is linear, it is positive, but weak, right? And then moderate is somewhere in between, and people normally like, that is a shady area, okay? And then, of course, if I pick up B, I would say it is linear, it is negative and strong, right? But D will be curvilinear. And for D, it's neither positive. It could be it's positive in some realm, in some region, and negative in some other region. Okay. But again, we're not going to be working with this. Just going to ignore that. We're focusing on these three. Okay. Any questions so far? So the first part of the class, hopefully by 10, we switch over to performing a function in SPSS and then come back and wrap up in the class. Okay, so let's go to the next slide. Is there any concern at this point? Any questions? No? Okay, so let's go to the next slide. And I think I need to stop this first. Okay, I didn't anticipate that. Well, this is recorded, so but all this we have to go away. So let me clear that and continue. Okay. Yeah, this technology is quite different here, and I think it's giving us challenges. It's not clear enough. Say that again, sorry. Yeah, and see if it will work, right? Use this to select, right? Oh, this one, right? Okay, okay. Let's try that. Okay. It's not working either, right? Okay. Okay, no problem. So we're not gonna let this waste our time. Can actually close this. I'm sure this is captured in the recording, so you can look it over again if you wish to. Okay, that actually went with that slide. Right, so the next slide here talked about how you talk about define. So here we're talking about this relationship. This should be graphically, not numerically. We're talking about it graphically here, right? In the next slide, we're going to talk about the same relationship, but numerically. So in defining what is strong, what is weak, or what is moderate, the range of values goes from -1 to +1, right? +1 will be the strongest. So if, for example, I have this relationship here, and all of the bivariate definitions are tightly packed on the same line. So this would be like a correlation of +1, right? The same way, if I have all of the relationship tightly packed downward this way, this will be like a correlation of -1. So it ranges in between, right? So it could become, any value in between, depending on how loosely packed it is. All right. So, but one thing to observe is that the correlation does not have any unit. We do not define it with any unit because the unit cancels out when you work this out. So first point to note here, when you're working, dealing with correlation numerically, is that it does not depend on the unit. So I could have kilogram, I could have hours, I could have distance, I could have anything. You don't define correlation with unit. Okay, and correlation measures only linear relationship. So in the previous diagram where I had something like this, a curved linear relationship like this, if you check the correlation, it could actually be 0, right? Kind of implying, or something very close to 0, kind of implying there's no relationship, which is not true. It's just that it is not linear. So we take note that correlation deals with linear measures only of the relationship. And then they are sensitive to outliers. So imagine, if I should draw another one here, imagine I have all these points trending this way, and then one point is just here, or a couple of points are just here. Instead of drawing the line like this, these points here, these outliers here, will be force the line to kind of change shape. So the line might end up going this way, right? So outliers do affect the correlation. Your correlation coefficient, or the value representing the strength of the linear relationship. Okay? So that value that you mark between -1 and 1 is called the correlation coefficient, and it denotes the strength of the relationship between the two variables. Okay, hope all this is making sense. Any question at this time? Okay, so that is really all we need to do about that. That is about correlation. So we don't want to go beyond that for this class. Again, if you need more on understanding nature of data that way, there is a whole semester class for this. We're going to go into linear regression now. So I picked up data from this person here, Mike Brown. I don't know who, but I just kind of liked the data set he put up. So we're going to work on that data set to do our regression. Okay, so I just wanted to have his link here to give him credit. I'm not recommending that or anything, but professionally, when you use somebody's material, you need to acknowledge the person. So that's what I'm doing here. Okay. So I picked up his data, and we're going to be using that to work on our regression. Okay. So if you go to the course website, that I have one open, let's do that very quickly. So you can go ahead and open the course website and open SPSS as well. Okay. So if you go to the course website, we're going to be working with this data here. Under unit 11, we're going to be working with the data here. There's the data here, correlation and regression data. Okay. I did a video here, short clip that is here. So what I'd want you to do in the next 15 minutes, if we can do that, is to open this video, follow the instruction on the video, download this data, of course, keep it in a location where you'd want to, open the video, follow the instruction on the video, and import this data to SPSS and complete the exercise as directed by the video. And when you're done, we all come back and then continue with describing the output from that exercise. Okay. So again, I have earbuds here. If you need more, so that we don't have everybody turning up their volume. But if you have one, that is fine. Again, last time I gave out this, I got only one. I got only one bag. Please, it's too pretty. I don't want to be accounting for them. I don't want to go to the rigor of making you sign up on the paper. I'll just take notes of those who are collecting. So if you need one, I will get that across to you. So open this video, download this data, follow the instruction on the video, open SPSS and complete the exercise on that. We'll give like 15 minutes. It's very short, it's 7 minutes. Give you like 15 minutes, or maybe 20 minutes to do that. Okay. So let me know, you just raise up your hand and I'll bring an earpiece for you. You say that again? Okay, okay. And you can work on this together with anybody on your side. Just let's say yeah, there's a lot. So, yeah. So you know, the instruction there will be added to the email where you can just yeah. So he will she will be a better person to help. Right. So if you go to the course website under unit yeah, she will be the best person to help. Yeah. But what I would say for the purpose of the exercises in class, you can take out time, come over here and do it in the lab using the office computer. Right? Yeah, and this place is open literally around the clock. Yeah, please keep the volume used here, please, something so that the information is So the final exam SPSS actually means you can do it anywhere. So you can come into school without window. I think the final exam SPSS. Yeah, the final exam class that have SPSS, you can do that. You have to do that. You have to so the first part, two part, one part is like this. That one is what I mean, yeah. Teaching part. Now, more information on that. Yeah, so I said more. So, yeah, so we have two products and take one part, right? Take one part, right? If I get it, two parts, you have to. Yeah. So more details about finals will be given next week. Okay. So let's run up on that one. Yeah. because you don't have this.
I had it on here.
Yeah. Okay, so
No.
okay, I can see some of you are joining the graph already. I'll give you like 5 more minutes. If you can't finish up, we'll follow through with what we have on the screen and you can finish it up later on, okay? Okay. Okay, so you don't have to copy and paste on a Word document if you're done. Like I did that video that way because you actually be copying and pasting on the homework assignment on this topic later. Okay. So, but for now, we are just going to go through the material you have, the way they are. I'll give you 2 more minutes. And again, if you are not done, you can continue after class. Okay, I think yeah, I can see on your windows a good number of you are done. So let's go ahead and work on this. I think we actually will finish maybe a few minutes earlier today, and you can continue. Okay. All right. So I have these things on the PowerPoint already, copied and pasted. You'll be performing similar. Where is this slide? You will be performing similar, completing similar homework on your own later today, or maybe any other time after now. Okay, so this is the one of the charts that you ought to have produced. I actually did this to make some illustration. I think I'm going to make it big. Okay, that is not working out. Okay, so let me extend this, make that very big so that we can see through and make it 2 pages to see the difference between the two. So delete that, I think. Okay. Delete this one and make this one big. So I wanted to illustrate here that if you mix up the variable, you actually get entirely different trend line. Sometimes they are similar, but there will be significant differences in the numerical values. So over here, so let's maybe look at this slide first. So this is what I ask you to do. All right. Yeah, so this is the one you would have produced. Achievements on the vertical axis and mastery on the horizontal axis. So if you have this kind of arrangement, what you're trying to do is to predict what is on the y-axis using what is on the x-axis, right? So we're trying to determine achievements, student achievement, I don't really know actually what this achievement record is about. So we're trying to determine achievement by mastery, right? So once you insert the trend line, you see an equation here. This is really the regression equation, and is the equation of the line. You may have come across this in algebra, and a simple expression like this one that captures the line, right? Okay, so I wanted to show you that this, if you look at this equation, this is 1.85 plus 0.52, right? If you look at that and look at the next slide, see that the equation is different. So in this slide, I just separated those two. I decided to use mastery on the y-axis and achievement on the x-axis. So this arrangement here is trying to predict mastery using achievement, which is like the opposite thing, right? Yeah, so there's a right way to do it and there's a wrong way to do it. You can see that the equation you get are totally two different equations. So this is the one you should have done, and this is the one that is properly placed. Okay, so we're trying to say if student studies and masters the content, does the achievement increase because of mastery? So we could see here that lower end, like if you pick up the value 2, let's say mastery at the level of 2, if you go up, meet up the trend line, then this is the expected outcome in achievement, right? For that mastery level of 2. And you can see this is trending upward, right? This is a positive relationship. So the higher the mastery, the higher the achievement. But does it mean that everybody who has achievements, mastery of unit 2 or measured at 2 units, we have the same achievements measured at about 2.8 units then? No, right? You could see a lot of people here. There's somebody here, there's somebody here, there's somebody here. You could see a lot of people. There are some people below the line. There are some people above the line. Okay, so if we kind of subset this area, we have all these people all scoring 2 in terms of mastery, but they have different achievement records. So there are variations. But what regression tried to do is to say on the average in the population, what is expected of somebody who has this value? In this regard, what is expected of the person on the other aspect, right? So this is an average kind of line. The trend line represents average across the board, okay? So we could describe this. I mean, how will you describe the relationship here? Based on what we did in correlation, right? Use the three criteria: the strength, the direction, and the shape. Okay. Anybody willing to give that a shot? And then we'll break it up. Let's do that in parts. What is the direction? Is this positive or negative? Positive, right? Okay, go ahead and complete that. So positive, what do you think about the shape? Okay, so we do emphasize that it's linear and curvilinear, right? So it's linear. And then what about the strength? Not very strong, right? And so in addition to this, we can also see a couple of things here. We can see a value here, R squared here, right? I'm going to try to see if I can capture. Let me see what I have on this slide here. Okay, so we can talk about that. So you could see a value here on the top right called R squared. And we're going to talk about that a little bit. R squared is also called the coefficient of determination. Okay, that's another name for R square, is the coefficient of determination. And what it is that it tells you how much of the variation in achievement is explained by mastery. Okay, and this is like using the context here. But generally speaking, what coefficient of determination, R squared, this value here, what it tells you is the percentage of variation in the dependent variable. Okay, and the dependent variable in regression is always your Y. Okay, so R squared tells you the variation in the dependent variable that is explained by the independent variable. Okay, in regression, the independent variable is always your X. Okay, so what you then do is that when you're interpreting this, you frame it on the context. So in this context, we could say, using R square of 0.330, if you convert that to percentage, that would be 33%, right? So in this context, we could say that mastery explains 33% of the variation in achievement, right? So if you measure somebody's mastery, you could use that to predict achievement, but up to 33% of whatever explains people's achievement, right? This is not real data, right? This is made of fake data. So what I'm saying does not really apply concretely that way. But of course, we know that in reality, mastery and achievement should have positive correlation, okay? So again, I will repeat that and maybe write it down here. So R square of 0.330 says that can be interpreted as 33% of the variation in achievement is explained by mastery. Okay, that is what this is indicating. And of course, you can phrase it in your own way, you know, however it comes across to you. But generally, this is what it's saying. The percentage of the dependent variable that is explained by the independent variable. So in our context, you must give it the context, right? Your interpretation will be based on the context. So in the context of what we are doing here, we are saying that 3% of achievement is explained by mastery, okay? Any question or concern about this? All right, so let's move on to the other output that you generated today. You have this model summary. So the model summary actually captures R square as well. So if you can see here, you see your R, right? And if you square this, you get R square, just as the name implies. So this is your R square. So if you have this table and this chart, you could pick up your R square from here. But if you don't have this chart, if you have this table here, you can pick up your R square also from the table, right? You could see that both of them give you the same value, right? So again, it says that 3% of the variation in the dependent variable that is explained by the independent variable, okay? And so maybe we should set this at this point. You know, the dependent variable is something as Y, right? It's normally the Y variable, right? And sometimes you also call it the outcome variable. Right? So the independent variable is your X, right? And sometimes you also call it the predictor. So they are just different names, and you come across this in different textbooks. Okay. So that is X. That seems to have written it very well. Okay. So it's what we can pick from here. We can also see adjusted R square or estimate of the standard error. We're not going to bother about this for now. Again, we're trying to just focus on very light aspects of this topic. So the next table I ask you to copy and paste is the coefficients. So if you did it well, again, these are the values you will have. Okay, so the coefficient also captures the regression equation. So if we go back to this, you could see the regression equation here, right? Let's try to take note of the numbers we have there. We have y equal to 1.85 plus 0.52. Okay, so notice that 1.85 is by itself, 0.52 is with x. Okay, and then remember, x represents the independent variable, which is on the x-axis, right? So another way of writing this equation is, you could write it as achievement and let me do it on the other page. I think it will be better. So let's take note of this number, 1.85 and 0.52 close to x. So if you look at this table, the coefficient table, you could see that 1.85 here as well. Okay, and you could see the 0.252 here. It's the 3 digits, so it's 0.524, right? And you could see that 0.52 is associated with mastery. And that is why on this chart here, you see it is close to x, right? Okay, so it's associated with mastery. So that equation of line could be reproduced using this table. So assuming you don't have that chart and you have only this table, you can reproduce the same equation. So we could write this. And generally speaking, the equation is written as y equal to bx plus c. That is the general form. Okay, you may have come across this in your algebra classes. And some other people would prefer to write it as y equal to c plus bx. They are technically the same thing, right? Okay, so let's rewrite this expression or write an equation for this model from this table as was reproduced in the graph. So here I could say y is equal to c is your constant. Okay, so the constant variable will come first here if I'm using the second kind of design. So I have 1.852 plus the value for mastery, the coefficient for mastery, which is 0.524. And I have my x here. I can put it in parentheses. So this is one way to write this, right? And if I start to use the other pattern, this other pattern here, I could write this as y is equal to 0.524 with x in parentheses plus the constants, which is 1.852. Okay, so these are two different ways of writing the same equation. But when you're doing this, you also want to place it in context because it's like general format. Okay, in context, we know that our y is the dependent variable. So I could say achievement okay, I'm not sure the spelling is correct, but you're here with me, so you know what we're doing. So we know achievement is equal to, let me use this version, okay? Achievement is equal to 1.852 plus 0.524 times mastery. Okay, so this becomes the equation connecting achievement and mastery. Okay, so what does the equation tell? It's a prediction equation, and we can use that to predict the outcome for someone who is not part of this analysis, right? So if, for example, we know somebody's mastery value, we can actually tell the expected achievement. And that's what they do in this admission processes. When they take GRE, start score and all that, they're trying to predict students who will be successful that they want to admit. So they take all these variables and in an equation come out with decision about who to admit, then they rank that and have a cutoff, right? And every system applies that in so many other different ways. Okay, so if, for example, I know that mastery is 0.9 for a given individual, I could compute the person's achievement. I just plug it into this question and that would be that, right? So if I know that math 3 is 0.9, then achievement for that person will be predicted as 1.852 plus 0.524 times 0.9. Just plug in that in place of mastery and multiply that, solve that simple equation, and you have the achievement value for that particular person. Okay, so this will be a simple exercise. You also will need to do that on the homework. Yeah, so that is that. Any question on that? Okay, the next important thing is how do you interpret these values? How do you interpret the constants, and how do you interpret mastery in this equation? I mean, the coefficient of mastery in this equation. Okay, so let's do that next. Let me see if I can reproduce this slide. Okay, so let's take away all of this and play that again. Okay, so how do we interpret these values? Okay, I think I did that with the last slide. This is the one I want truly. Okay, good. Okay, so how do you interpret this constant here? Right? We interpret the constant term we interpret that as the value or the achievement value. So I'm doing that in context now, right? If I'm working on another thing, I will use the name of what I'm working on. So we interpret the constant here as the achievement value that is associated. And again, these are all my expression. You can write it in your own words, but the key things must be captured, right? We interpret the constant term as the achievement value that is associated with an individual whose mastery is 0. Okay, look at that. So what we have in the equation is achievement is equal to 1.852 plus 0.524 times mastery. Right? So imagine if somebody's mastery is 0, if I put in 0 here, if you multiply 0 by this, all this goes to 0. Right? If you multiply 0 by anything, of course it becomes 0. So you end up having, if you solve that equation for somebody whose mastery is 0, you end up having that achievement is equal to 1.852. So you see that is the interpretation we're giving the constant. Does that make sense? Like it's very straightforward, right? So your achievement is, your constant term is interpreted as the value given to an individual, or the achievement value for an individual with a mastery of 0. Okay. Every time, right? So for a given situation, right? So if, for example, I don't have mastery here, I have another variable there, of course, we define them the same way, right? The constant will be the value of the dependent variable for someone with 0 value on the independent variable. Okay. And again, remember, this is a simple linear regression. In real life, you don't predict anything using one variable. It's technically, close to impossible, right? Most things in life, when you deal with human beings, most things in life are predicted with so many variables. So normally what you have is not a simple linear regression. In most cases, usually we'll have a multiple linear regression where you have so many variables trying to predict one outcome, okay? So again, in that situation, you will just have a bunch of values. So it will be like you have y is equal to your constant plus b1x plus b2x plus b3x, right? Each of these representing different variables. Again, your constant in that term will be described as the value of a person who has zeros in all of the other groups. Okay, so good observation there. Any other question or concern on this one? All right, so again, when you are defining this thing, define them in context, right? We are saying achievement, the constant term is the value of achievement for somebody who has 0 score in mastery. Okay. Then how do we interpret the coefficient for mastery? Okay, let me reproduce that again. I think we have that actually. So how do we interpret the second coefficient here? Okay. So the coefficient for mastering this is interpreted as follows. This coefficient will indicate that 1 unit increase okay, it's like we're gonna have a problem with this. So this will indicate that 1 unit increase in mastery will lead to a 0.524 units increase. In achievements. Okay, again, I am using the words that are in the context. So if this is not mastery and achievement, just use the right words, right? So the coefficient for mastery here, which is 0.524, is interpreted as follows. It will imply that every 1 unit increase in mastery would increase achievement by that coefficient. Okay, and this is what the pattern, this is the template, this is where it's interpreted all the time. Okay, so again, if you look at that equation, y is equal to 1.852 plus 0.524 and mastery in parentheses here, or so let's say x in parentheses here. So you see that if you double the value, if you put 1 here, right, for example, so 1 unit hit there. If you solve this equation, you find out that this shifted by only this amount. If you put 2 here, if you solve this equation, you find out that achievement will shift by 2 times this value here. So whatever value you put here, so this marks like the increment for every 1 unit, and that is the interpretation. Okay? So every 1 unit increase in mastery will lead to the value of the coefficient increase in achievement. Okay, and maybe as a template, you could say, let me use another color to do that. Okay, my writing pad here is given a problem. Let me write that on the board very quickly. So as a template, I'm going to put this in parentheses. The coefficient. Yeah, is the increase. So this is all you need to do is remove what you need to remove and put in what needs to go there, right? Independent variable for us here is mastery. think I have another sign. Yes. So the independent variable. The coefficient variable for us is 0.54. The dependent variable for us. So if you just replace that, then you have a template for interpreting the coefficient all the time. Okay, so but pay attention. You see what we did before? If you switch dependent and independent variable, you have entirely a different prediction equation. So you must be careful to know that I am trying to predict this with this. And whatever you're trying to predict will be on the y-axis. Whatever you're using to predict it will be on the x-axis. Okay. All right, any question on this? Okay, so I think essentially that is the last slide. Let me switch back to, okay, we can keep it on. So this is what you'll be repeating on the assessment. And I'm not sure there's anything else I'm missing here. Yeah, I'm not sure there's anything I'm missing, but I could end the video very quickly and then look at the question you were asked. Okay, I think I can keep it on. Let me look at the exercise I'll be giving you and make sure that everything is covered. But is there any question at this time? Okay, so I'll be posting this exercise later today, exercise 4. I'll be required to just repeat most of the things we've done today, more or less in the same way. Oh, I think I have the keys there, but that's okay. Linear regression, I did all that. The combination coefficient achievement. Okay, I think everything is pretty much covered. So is there any question or concern before we end the class? All right, so just watch the video recorded again. I'll be posting this video just after class. Using those to complete an exercise that will be posted there, and that exercise will be uploaded in 11.2. So 11.1 is just asking you questions on some of these concepts we talked about, concept regarding correlation and concept regarding regression. We're going to have some concept question here, but complete this exercise I'm going to be posting after class and then upload it over here, right? Upload your file over here, okay? And that exercise will be repeating almost everything we've done in class today. Okay. Any other question? Okay. Okay. If I gave you here, short there's attendance here, short mark on that, okay? And your exams, quiz 2 are also here. Pick up one and review them, and let me know if you want it to be graded differently. And we will do that. You have until Tuesday next week to do that. Okay. All right, so I'll be here from now till 12:30. If you have anything to work on, just stay behind and I'll work with you, okay? All right.
Sorry.
Thank you. Oh, okay. I was wondering because I didn't give you one today. Thank you for bringing it back. I'm gonna end recording now.